Hello, everyone. Hi, so my name is Thomas, and I'm a developer relation engineer working on AI and Android. And so today we are going to talk about AI and show you how you can leverage it on your AI glasses applications. So let's review the agenda for the session. So we'll start with covering the Gemini Live API and Firebase AI logic. And we are going to take a standard Android app using Gemini, and we are going to transform it into a multimodal agentic experience on AI glasses. That's the plan for the session. So let's start by talking about generative AI specifically on Android. So here is what we are seeing today. Users expect personal, intelligent, and agentic experiences on their Android devices. And our goal is to provide solutions across all our form factors to enable helpful and seamless interactions. So to do that, Google is actually thinking of AI solution as an end-to-end stack that includes the TPUs, the chips we are running inference on, models, and also all the way down to applications. And we are implementing that on both cloud and on device. And we are also supporting a comprehensive developer experience by providing a set of models, SDKs, Google AI Studio that helps you create and iterate on your prompts, and also code samples that lets you see AI capabilities in action. And this is the toolkit that will enable you to build the next generation of Android apps leveraging AI. So in this session, we are going to specifically dive into the Gemini models that are running in the cloud. And the Gemini family has 3 classes of models running in the cloud. So there is Gemini 3 Pro that was just released a few weeks ago. That is basically our flagship model. It's the most capable model that you can use today. And there is also Gemini 2.5 Flash, which is best in terms of price-performance ratio. And finally, there is also Gemini 2.5 Flash Lite, which is optimized for cost efficiency and low latency. And the Gemini models are incredibly versatile. They can process various types of data, such as text, images, audio, and even video. And depending on the model, you can get outputs that are either in plain text, or JSON, or even images or audio. And you can use the Firebase AI Logic SDK to directly access those Gemini models. The Firebase AI Logic SDK is a dedicated SDK for Android that makes the integration easy. And in addition, it actually provides some tools that prevents API abuse, and it integrates seamlessly with other Firebase services. So let's actually take a look at how Firebase AI Logic works. So you integrate the Firebase AI Logic SDK in your app, and it will basically act as a bridge between your application and the Firebase backend. And then from the Firebase backend, you can access Gemini Flash and Gemini Pro models either running on Vertex AI or on the Gemini Developer API. And so if we take some minutes to talk about those 2 API providers, you can think of them as 2 different backends with distinct features running the AI models. So first, there is the Gemini Developer API. It's great to start. It offers generous quota at no cost. And it still easily lets you upgrade to a paid tier as your user base grows. And alternatively, there is Firebase AI. There is a Vertex AI rather that is great if you are already using Google Cloud. So we talked about the Gemini models, and we talked about Firebase AI logic, but let's look at one specific API that is particularly interesting when you are building for AI classes. It's the Gemini Live API. It's currently accessible in preview in the Firebase AI logic SDK. So you might already be familiar with Gemini Live. Gemini Live is a feature in the Gemini application that lets you talk to the model and let the model respond back to you. It's actually one of the primary methods to interact with AI classes. But the Gemini Live API is a developer API that is currently in preview and enables you to build a similar experience, but within your application. It lets you basically implement voice-to-voice interaction with the Gemini models, but for your own use case in your own app. So the architecture when you use the Gemini Live API remains the same. You have the Firebase AI Logic SDK talking to the Firebase backend, and the Firebase backend talking to the Gemini model. But specifically for the Gemini Live API, there is a WebSocket connection that will be established between your app and the Firebase backend to enable real-time bidirectional communication. And it's fully managed by the SDK. OK, so now that we talked about the Gemini models, let's take things a little bit further and see how we can build an AI agent. But I guess the first thing we should do is define the concept of AI agent. So there are a few definitions out there, but I think what we can say is that an agent achieves goals, it plans and reasons about its current state, and it acts and observes the results. And all of that while using tools that are made available. So usually AI agents are pretty complex systems, but in our case, we will basically assume that the AI agent is the Gemini LLM with some tools that are provided to the model. So to illustrate this, we will actually use the Gemini Live API to-do sample application. So the code sample is actually from the AI sample catalog that is currently available on GitHub. And it's a very simple application. It has a simple screen that lets you add and remove tasks to a list. And we are also integrating the Gemini Live API to let you do those things with your voice. So you can think about it basically as a to-do list application with a built-in voice AI agent. And so let's see it in action.
What are the items on the list?
The items on the list are read a book, buy eggs, do the dishes, and buy bread.
Okay, can you mark do the dishes as done?
Marked do the dishes as Ben.
And can you also delete read a book?
Removed read a book from the list.
All right, so to implement this, we actually used function calling that is supported by the Gemini Live API. So if you're not familiar with function calling, it's actually a relatively common LLM paradigm that enables the model to call a specific function in your code. So for example, we let Gemini know that there's a function called add to list to add new items to the list. And we also have a function called remove to remove the items. So if I say, for instance, add buy milk and remove buy bread, the model will do basically two function calls in a row. So let's take a look at the sequence of events. So we start by providing add to list and remove to the model. So the model is aware that those two functions exist. And then when the prompt is passed, the model will basically reason and plan the next actions. And then it will decide to call add list with buy milk as a parameter, and also call the remove function with buy bread as a parameter. And finally, the model will confirm that the goal is accomplished. So let's see how it works in the code. So first, you need to create a live instance, a live model instance at the very top. And you can see that we are actually using system instruction. So it's actually a way to define the tone of the model and define its behavior. So here we make it basically a helpful voice assistant, but that's also something you can use to kind of like limit the things that the model can actually do and keep it on the specific task. And then we call connect, that will create a session, a voice session. And finally, when we are ready to start the voice interaction with the model, we call start audio conversation. So you can expose the add to list function by instantiating a function declaration and providing a description of the function and its parameter in natural language. So here you can see I pass the name, and I also provide a description saying exactly what the function is doing. And then I pass a map of items, basically providing the parameters with also a description of what they do. And you will also have to implement a handler function to basically be able to dispatch the calls of the model to the right functions in your code. So you can learn more about the Gemini Live API and function calling in the Android documentation. And actually, as mentioned earlier, if you quickly want to test the Gemini Live API without having to install anything, you can also go to Google AI Studio and play with it directly in your browser. So you can, for instance, try system instructions to define the tone and the behavior of the model. And you can also test and validate your function calls. And with that, I will pass it to Kathleen that will walk us through how to build it for AI glasses.
Thanks, Thomas. Hi, everyone. I'm Kathleen, and I'm a developer relations engineer working in XR on AI glasses. We just saw the incredible power of Gemini Live API adding agentic capabilities to our mobile to-do list, and now we're going to take that app and extend it onto AI glasses. I'm going to focus strictly on the technical implementation here, but if you're interested to learn more about the design side of it, definitely check out the Designing Audio Interactions on AI Glasses talk happening right after this session. So, in order to get the to-do list sample up and Gemini running on our newest form factor, we are going to take advantage of the new features we introduced in the Android XR Developer Preview 3. To extend the to-do sample, we are going to leverage two brand new libraries, Jetpack Projected and Jetpack Compose Glimmer. We'll walk through the setup for both the phone and the glasses, and I'll show you how to reuse the exact same view model that Thomas showed you from the mobile app. Along the way, we're also going to cover the unique considerations you need to keep in mind when building for this unique form factor. So, what does it actually take to get the code running on glasses? The setup is surprisingly simple. The most important thing to know is that unlike immersive XR headsets, the code doesn't run on the glasses. It stays on the phone. Jetpack Projected handles that bridge for you. It launches a dedicated glasses activity on the phone which projects the UI over to the glasses. This allows you to render a visual interface and tap into the sensors like the microphone, camera, and IMU. And if you didn't catch the talk earlier and want a deep dive on that app lifecycle, I encourage you to check out the Getting Started Building on Glasses talk, which will be available on YouTube after the event today. So, let's now look at the code for how to do this. We use projected context to tell the OS that this activity should project onto the glasses, rather than on the phone screen. This setup is key for efficiency. It allows us to preserve the resources on the glasses by using them strictly to render the display, while the application logic stays on the phone. And since we're having a two-way conversation with Gemini Live, we also request for microphone access. So, with the permissions handled, we're ready to build the UI. And for this, of course, we're going to use Jetpack Compose Glimmer. Jetpack Compose Glimmer is our new design language, and Compose UI Toolkit built specifically for AI glasses. In the code, everything lives inside the root screen composable. We apply the Jetpack Compose Glimmer theme here and pass the permission state down, guaranteeing that the UI only loads after the glasses have access to the microphone. And since we're running on glasses, we always need to make sure to watch our resource usage. But just as importantly, we need to respect the user's intent. We want to make sure they decide when the microphone is on, so we set it to trigger via physical gesture. When the user taps the frame of the glasses, that sends a signal to toggle the AI session on the phone. It's a clean way to manage both battery and privacy. And now, because we have access to everything that the phone sees, hooking up the data is easy. We are able to utilize the exact same view model from the to-do list sample and drive the UI on the glasses. And in the code you see here, we're taking that data and feeding it into a Glimmer list to render the items on the display of the glasses. So finally, let's take a look at the result.
Hey there, what's on your mind?
Could you check off read a book?
Got it. Done. Anything else?
Awesome. Maybe you could just delete do the dishes?
Okay. Do the dishes has been removed. What else?
Amazing. Now could you just add to my list, build more Gemini apps?
Okay, I've added it to your list. Anything else?
No, that's it. Thanks so much.
No problem. Have a great day.
Here I am testing the prototype on glasses. You can see I'm just having a natural two-way conversation with Gemini Live. Gemini handles all the logic, so when I ask it to add items, check them off, or delete them, the UI on the glasses updates instantly. So, to help you get started, we are sharing the full code for this AI glasses prototype. You can find it right now in the Android AI sample catalog on GitHub. Just be sure to check out the prototype/AI/glasses branch to see everything we walked through today. And with that, I will now pass it off to Anthony, who will walk you through how to build a multimodal experience for AI glasses.
Thanks, Kathleen. Hi, everyone. I'm Anthony, and I'm a software engineer on the Android XR team. So Tomas started us off by walking through the to-do sample on mobile, and Kathleen showed us how to adapt that for our AI glasses. In this next section, we'll take our sample a step further by enabling the camera, allowing the agent to see what you see, while still ensuring we only share this visual context when the user grants permission. So when building an in-app agent for our AI glasses, we can provide it with more than just audio. We can integrate visual and sensor input as well. It becomes a multimodal agent with your point of view. Using signals like GPS and IMU tells the agent where you are and where you're looking. It can see what you see and hear what you hear simultaneously to understand your real-world context in real time. You can learn more about leveraging sensor input in the What's New in the Jetpack XR SDK talk. Right now, we're going to focus specifically on adding visual input. So let's extend our to-do sample to support multimodal interactions on our AI glasses. Our goal is to enable a flow where a user can simply hold up an empty carton of milk and say, add this. So our agent needs to do a few things. One, capture the image. Two, understand that this refers to the visual object, the milk. And three, trigger the existing add to list function in our app. So to do this, in addition to Jetpack Compose Glimmer, we utilize a new preview API in the Firebase AI Logic SDK and the Camera X library for the vision pipeline. How many of you have used Camera X? Nice. Well, if you aren't familiar with Camera X, it's a Jetpack library that simplifies camera development. It provides a consistent API that works across the vast majority of Android devices. Before we look at how we feed the visual data to the model, we first need to define how it behaves. We'll use the system instructions that Tomas showed us how to configure in Firebase AI Logic earlier. We are evolving the persona from a helpful voice assistant to a voice and vision assistant. We explicitly tell our model, you should be ready to process voice commands or analyze camera images. We also need to define a vision protocol in our system instructions. Cameras on glasses consume power and can raise privacy concerns, so we can't just leave them on all the time. We instruct our model that the camera is not always on. When the user taps on the camera button in the app, we send a text signal to let the model know that the camera is now on. Now, when the user says, add this, the model knows it can look at the video stream to resolve the query. If the video is missing, it knows to ask the user to enable it. Now, let's look at the plumbing. Earlier, we saw how to initiate an audio conversation. So let's look at another key component for our AI glasses, the visual pipeline. We utilize Camera X's image analysis use case. In Camera X, a use case simply defines the task you want to perform, like showing a preview or taking a photo. Image analysis is the specific use case that gives our code direct access to the raw frame buffers for AI processing. So cameras are fast, capturing 30 to 60 frames every second, but this isn't necessary for our application and would rapidly drain the battery. So there are three critical configuration details here. First, we use our recommended AI strategy is capturing 1 frame per second at VGA resolution, 640 by 480 pixels. Second, we use strategy keep only latest. This is vital for real-time AI. If our analysis logic falls behind, perhaps because our network is slow or our device is under load, we don't want to process the old frames. Third, we attach our custom image analyzer. This is where we hook into the camera context to extract the frames and run our throttling logic. We implement our custom image analyzer to handle throttling, limiting our input to just 1 frame per second. Inside our analyze loop, we check the system timestamp, and if a second hasn't passed, we skip processing. When we do capture a frame, we convert it to our bitmap and pass it to our callback. Finally, we call image.close. In Camera X, if you fail to close the image, the buffer continues to fill up and the camera pipeline stalls. So the close call must happen regardless of whether we use the frame. Finally, we have the bridge to the model. We take that throttled VGA bitmap and compress it to a JPEG. We set the quality to 50%, which reduces the payload size while maintaining enough detail for the model to do recognition. Then we use the Firebase AI Logic send video real-time method. This is a preview API, but it pipes the visual data into the active WebSocket session. Now the model receives a live view of the user's world alongside the audio stream. All right, let's check out a demo.
Now I can see what you see.
Can you add these tasks to my to-do list?
I've added schedule meeting and 3 other items to your list.
So as you just saw, after we enabled the camera, the agent recognized I was referring to the list in front of me. It transcribed exactly what it saw, and the handwritten notes are now added to our to-do list. So let's quickly recap the journey we just took. We kicked off things with a mobile app, building a conversational agent that can understand natural language and execute tools. Next, we extended it to glasses. And finally, we went a step further to add multimodal features that take advantage of the AI glasses form factor. And we did this all using tools and libraries available today: Camera X, Firebase AI Logic, and the Android XR SDK. Head on over to developer.android.com/XR for everything you need to start building for AI glasses today, including the AI glasses emulator. You can also find the prototype to-do sample that Kathleen shared. So download them today. We're excited to see what you build. Thank you.